Because imagine you have two processes, they're supposed to be isolated from each other. If you took memory from one, it's free, that goes back to the kernel, and the kernel handed it off to another program, you would leak information from this program onto that program. That's not a good thing, right? And so I was saying earlier, performance-wise, allocators try to avoid zeroing because it has a cost. Well, the OS can't have that latitude. It has to clear memory because there's a clear security boundary between processes, and so it has to do that zeroing, right? Otherwise, the OS would leak information from one process to another. That's a bad idea. Okay, so mmap is our function to handle memory mix. Let's look at what it looks like. Well, when I try to call it, right, to just allocate stuff into my process, this is typically what you would do. First, you'd figure out what the page size is, right? So there's a sysconf that you can ask the page size for. It'll tell you 4 KB or something like that. And then you'll call mmap, cast the result to a char star. If we're doing C++, right, if we want to have bytes, you just cast the char star. And then the first parameter, the address, you're going to pass a null to it. So there's a bunch of stuff that you can do with mmap. We're not going to try to do these things. What we're trying to do is to just say, give me memory, right? And when you say, give me memory, you'll use map private and map anonymous, and you'll say, I want to be able to read and write to those pages.